This is part 2 from the video that I had made before for Dr. Lewis Calculus 1 class. I was explaining the derivative of the trig functions before the camera got cut off. So just going back, just to roughly explain it, this is everything that I had, which involves the 6 derivatives of the trig functions right here. And I had previously explained them in my previous video before it got cut off. So the last thing that I'm going to explain is the chain function, which is what we have been doing so far in class. Basically, the chain rule involves taking the derivative of the outside, leaving the inside alone. The answer to what causes a person to have a chain rule is when you have more than just x or t or even g or whatever variable is used in the function. So we have an example right here of a chain rule, which is f of x is equal to -5 cosine of x, all to the exponent of -4. So we take outside function right there. We take the exponent, multiply it by -5 to get 20, reduce the power by 1, which gives us 20 cosine of -5, reducing the power again by -1 of x, and taking the derivative of cosine of x to get negative sine of x. After 1, we take 20, multiply it by the negative in front of the sign to get the final answer to equal -20 cosine of -5 of x sine of x. So that is everything that we have right there. So just a quick review on everything that we talked about. We talked about the derivative of a constant, power rule, constant multiple, the quotient, the product. We just talked about the chain rule. We talked about the 6 different trig function derivatives. We also talked about the definition of a derivative of a function with respect to the variable x as h approaches 0. We talked about derivative equals slope equals instantaneous velocity equals instantaneous speed. And if a function is not continuous, it does not necessarily have to have a derivative. If it does have a derivative, it's continuous. Those relationships go hand in hand. We talked about the point slope formula and how it could be used along with the definition of a derivative to find a tangent of a line. And we also talked mainly about what d over d of x is, which is just stating that derivative of something equals this. Okay, thank you so much.